So welcome back to COMP335, Communicating Computer Science. Today we want to talk about the national curriculum in computing, just as a little bit of background so that you know what children are supposed to learn in school. I wanted to say a few words about the education system. Now, many of you went to school here, so you know more about this than I do probably, but some of you are from abroad like me, and so we'll look at that briefly. And then what happened to computer science in that context. And we'll look a bit more in detail at key stage 3. So well, we'll cover that. That's years 7, 8, and 9 usually. Because that's the target age group for our taster days. And I'll talk a bit about widening participation. I try to make one table that gives the key division of years into school types. Now, when it comes to the UK, the school system is complicated and fractured. Not all schools follow this. There are private schools that don't follow the national curriculum at all, even though not many. Usually those are the ones that do much more, or they're on the esoteric end of the spectrum and do things quite differently. But the vast majority of schools and state schools seem to follow roughly this division. So there's 6 years of primary school, starting with year 0 if you want, reception class, which is a transition from early childhood education to school. Playful, but a little bit of learning. And then the old school system was to have a big central test at the end of primary school, and then that decides if you go to a selective grammar school or a comprehensive school. Now, most places have abolished that system, also because this test seems to have been quite stressful for kids. But there's some exceptions. Some counties still have it. The Wirral is one of those, which is just next to Liverpool. Then secondary schools, irrespective of whether that's grammar or comprehensive or whatever other school form, covers the next 5 years and ends with the biggest exam probably for most, the GCSEs. And that's also the end of the compulsory school education that you have to go through under normal circumstances. And then you can continue with A-levels in a sixth form or college. These often are combined with a secondary school, so they can be in the same building, etc., same institution, but formally they're separate. Any questions or comments, amendments so far? That's just the rough big picture. Oh, really?
Yeah. Essentially, what is now the test you have to do before you get accepted on the job is just that. Year 11 doing.
So you're saying it's like an assessment center kind of test for job interviews, the 11 plus?
Yeah, prologue.
Yeah, I think there's a reason why many places don't do it anymore. Now, my son's in year 4 on the Wirral, so and he eyed some grammar schools, so maybe he'll have to go through it then. Okay, so this is mostly irrelevant for us because we're looking at secondary schools as our main target, but just for background. Some bits about GCSEs as well, because what I probably it's on this one. So GCSEs is a certain standard of an exam in certain subjects, but you can choose which ones you take. And so the exams are always at the end of year 11, but you can choose which subjects you take, and you can even do more or less. And well, I think 5 good passes, that's the bare minimum for most employers. You probably want more, but and this plot shows a bit what people call grade inflation. So you see that the top marks over time made up a bigger and bigger fraction, at least in the long run. Now, so if you go just back a few years, seems more stable. But still, 2019, people switched from these letter marks to now numerical marks, and the 9 should be regarded as above the old A star. So I don't know, this might be after you've done it, hopefully. So I don't know how well known this is. So the mark system has changed a bit there. I think to tackle grade inflation. So it was, people found it was silly to say, okay, let's try to just push back on the letter system to have fewer A stars. That seemed hard to sell. So instead, they just added another grade on top. You know. Yeah, so people are probably just converting them still because that's what you're used to. That's why you still measure your weight in stone. Come on, guys. Okay. I'm not sure. So this is probably what I read on some website, hopefully the government one. Right. Yeah. So you're saying basically the 4 should be below here? Okay. I'll check. The thing is, why would you have so many levels of failing, right? It's either it's fail or not fail. Uh-huh. Okay. Right, right. Okay. Yeah, in a way we have this at uni too, right? There's not just below 40. Okay, I'll look up where I got this. In terms of the subject choice, this seems to be a hard one as well. There's a ton of subjects. Not all schools offer everything. Not even the length of Key Stage 4 that leads to GCSE is the same. Some schools went to 3 years. Say they give kids more time to prepare for the exams. Then a few schools, a few teachers I talked to say, oh no, they went back to 2 years because they felt the kids need more time to choose. So it seems like we'll have to live with the situation that you either have 9 and 10, 10 and 11 or 9, 10 and 11. And so the choice for the subjects can be in year 8 or year 9, and there might be even exceptions to that rule. What subjects do you take? So there's a few that you have to do. You have to do you have to do maths and English, and you have to do some science, which could either be the smaller version called combined science, in my understanding, or you usually do triple science, the 3 subjects as individual GCSEs. And then usually you're forced to do some things in addition where you have a lot more options. And computer science counts as one technical subject where you can replace it with something else. And you have to pick usually one of the other categories as well. My understanding is you can take as many as you want as long as your schedule allows it and you're not going completely crazy. But I don't know how realistic that really is. But the point is, computer science is an option there for GCSEs, but it's one among many other things. And so unlike the sciences, where most kids that have some interest in STEM, science, technology, engineering, mathematics, they often go for triple science without much second thought. For computer science, I think that's not necessarily true. That's my impression. And so here's the consequence of that. Now this is a bit hard to read. I don't know. So you see, maths is basically the number of students because everyone has to take it. So that shows you how many students in each year group you have. It's a little short of 1 million. And then for the other subjects that are electives, these are further down. So even physics, etc., the triple science individual subjects are here. Now, if what I said was true, right, we should have biology, chemistry, physics basically as the same line. I can't see chemistry really. I think it's behind the green one. So that would support my hypothesis that if people take split the sciences, they take all three. Yeah, and then computing is down here. You should ignore the first bit because there was a time when we had IT and computing both offered, or ICT. And that was somewhat popular, way above the level that computing now is, or computer science, I should say. And we can discuss that a bit. So one thing that's confusing is there is a core subject, computing, that everyone now has to take throughout Key Stage 4. So till the end of year 11 when you do GCSEs. However, that's not the same as choosing the computer science GCSE. So there's a little bit of base level computing that everyone does. And we'll come to what that covers. We'll cover what the curriculum says. What arrives at the students is not always the same. And the computer science GCSE courses go quite a bit deeper than that. So I think the difference between the two is substantial. So why that dip from, you could argue whether ICT and computing should both further be up here, or at least at the level of the sciences. But why was there this dip down from ICT down to computer science? Allegedly, ICT was a relatively simple subject, or perceived as a simple subject, and computer science is perceived as a harder subject to get good marks in GCSEs. And that's at least one possible explanation. It's not so clear if that's all, right? Another issue is a new subject, so schools only started offering it, so that's probably the initial slope. By now, this should not be such of a problem. But that's where we are. So let's try to zoom in a bit what computer science really means here. So I mean, you have a grasp of the field. I always like to show this also when schools come. Instead of defining in one sentence what's computer science and struggling with finding a good comprehensive sentence, I like to show a lot of examples. And so this is from some guy who makes a lot of these maps of different areas, and he's fairly diligent. I think it's quite well done. There's not a lot missing or misclassified or so on. And he has a nice YouTube video where he goes through it bit by bit. The important high-level color coding is there's this engineering side, building computing machines, there's the theory side, and there's applications where you take this computer science technique plus something else. And so that's also what I'll try for the taster days, show the kids something from each area. So I'll try to balance your lesson topics a bit, well, balance the schedules by choosing the lesson topics for the days, so that we show them a bit from all the different areas. I mean, you probably have some understanding of most of these bits, and you can probably have a feel for how different they are in how you apply them, or how what type of jobs they could lead into. So my point here is it's quite a diverse field. Programming is just such a tiny bit of it, maybe somewhere here, and there's a lot more to it. So which also means if you're not so much into programming or into building robots or whatever other bit that is dominating the public perception, that doesn't mean that computer science is not your thing. It's so broad that you may just find your other niche for where you're comfortable. In terms of curriculum, I asked you to watch this talk by one of the architects of the national curriculum document. I think it's a very nice talk and very compelling. Let's have a brief run through what you've done there. So that's the last one. Probably have to show this from here. So what's the definition? That's pretty much just copying what he said or what he had on the slide. But it's good to recap that. He says computer science is starting with the term. Did he say computer science or computing at that point? Well, let's say his definition of the field is the study of information, computation, and communication, and both in natural and in artificial systems. I guess that's what you all found. So far, so good. He lists a lot of reasons why we want to teach this to everyone. Yeah, one thing he picks up on is an overly heavy focus on the skills and technology side in the previous curriculum. And he wants to fix that to bring more of the subject discipline in, as it is in other fields. Yeah, another big thing he picks up on is this idea of having agency in the world. So not believing that some outer worldly people in the Silicon Valley build these devices and program them for us, and we can just live with whatever we get from this. Well, I asked you about the number of myths. I was just checking if you watched it till the end, I guess. And this is the bit where a bit more open. So what kind of examples did we see? We're teaching a concept that doesn't really teach a skill or a technique or technology, but really a conceptual idea that's key computer science. Okay, one example I saw was the sorting network video. Okay, concept of buses. You want to comment on that? I don't remember what he said in the video about that. Or is that, well, it's maybe from outside the video. Yeah, okay. Yep. Yep. Yeah, the finite state machines with the words. Yeah, communication. Like there's a lot of fundamental problems around communication, not just the key exchange that he alluded to, but other things like in distributed systems, how can you build consensus if you can't trust people? There's a lot of things where there's hard mathematical, theoretical advances that led to things. Right, cool. So I hope you found the video somewhat helpful. You learned something from it, or at least it was a bit inspirational. Now, okay, yeah, before we come to the curriculum, I think this is the way I try to use the terms in the module matches somewhat what Simon used. So he says computing is the entirety of the subject. That's why the national curriculum also bears that name. And it has subfields: computer science, information technology, and digital literacy. And so computer science for him is a subset of computing, where that's the focus on the scientific part. So all these questions that we discussed, I guess the question was correctly computer science. That's information, computation, and communication. IT is probably quite clear. That's all the hardware things plus what's needed to build them. Digital literacy is a bit more vague, right? I think it's part of it is being safe online and all these soft areas, but there might be a few more technical sides to it. I mean, a minimal amount of programming and understanding what computers can do might be counted as digital literacy as well. Yeah, so just be very, I'll try to use the terms like that. So computing when we talk about a bigger subject, and computer science when we talk about the slightly narrower scientific practical study of computation. But it's not how everyone uses the terms. All right, so he gave this long talk, and that's what they came up with. That's the national curriculum. I don't know if you've looked this up before. The thing that's staggering for me, this is it, right? This is the whole thing. It's these 3 pages. And it covers all the years primary up to GCSE for the core subjects. So this is necessarily super high level. If you zoom in a bit, I don't know if you can at all read this. Let's zoom into the key stage 3 bit. Okay. Doesn't like the zooming in too much. Running out of, I probably shouldn't have done this. You will see that it lists very high level principles. Almost nothing about how you teach that. And even the contents themselves are just an example. I'll try to rescue that. Okay, 71 out of RAM. That's not good. A much more stable model how to handle this. If you run out of RAM on Android, there's a clear process to close some apps, and to a good degree, not much else happens. Desktop, laptop operating systems are still not that stable. You're not supposed to let it happen. All right. Shall we dare to try again? I'll go one step at a time. Not touching it? Okay. So computational abstractions that model the state and behavior of real-world problems and physical systems. So it sounds like writing some simulations. Is that discrete event simulations, or do they program that in Python, or do they just ponder about this on a piece of paper? That's left open. Other things are more concrete. They should learn 2 programming languages. Some probably is Scratch plus Python these days most of the time. And a little bit about some data structures. So that's already substantial, right? They should learn a little bit about the basic building blocks there, and some Boolean logic, and a few other things. But I think you see for every topic, it's just this 2 to 3 lines of text. It's very high level still. Oh, Scratch. Yeah, something block-based. I think that's what's meant. Because this is what, if you start from key stage 1, etc. So I've seen this in primary school. They all learn a little bit of Scratch Junior, and they build some scenes or little animations. And so that's all block-based, so they don't have to be bothered with the syntax of some programming language. Pardon?
Yeah, good human resource machine, which is similar to Scratch, but simplified, gamified. Very, very good.
I think one problem in that space is it takes a lot of time for some new ideas to get to the classroom. And we'll get to that with the lesson planning a bit, right? It's just a lot of effort to change your lessons. And there's some friction, right? You have to be a threshold better than what's there before, plus robust and scalable and all these things before it gets adopted. but I'm not I'm not surprised that there's better things than Scratch by any means. Now, what happens when such a document gets published, which is very vague, but the schools are forced to adopt it? Someone jumps in and develops a curriculum, and this is depending on the subject, can be different players. In more traditional subjects, I think often the publishers of books stepped in and did that. So for maths, there's certain standard books, and then teachers can grab them. They can even buy more material that goes along with the book. For computing, it seems that we found a different way. There were basically two in parallel. So what started from this initiative of bringing computing into the curriculum is a grassroots organization, Computing at School, which is by and large a big forum for all computer science teachers. You can just, computing teachers, pardon. You can just go there, make an account, and then you can share your ideas. And it's as structured as this sounds, right? It's super hard to find anything and navigate. On the other hand, there's lots of people full of energy there. However, it took, for more than a decade, the curriculum was there, and I think it's still patchwork. That they wrote a document with some more concrete ideas how to teach this. I'm not sure how successful it was. There's another attempt now, which is more recent, which is a bit more top-down. Basically, the Raspberry Pi Foundation got a lot of funding and is now investing heavily in building curriculums. And they came up with a full curriculum for the entire stages. For every little lesson, they worked out exactly how you can teach this. It's a massive resource. I think it's only been finished last year, so I haven't met a teacher who says, yeah, I just took this and applied it, because they all had something that they were developing themselves by that time. But it's an interesting development. So I encourage you to look at both a bit. Again, mostly background knowledge, but what's useful for this is if you want to gauge what are kids likely to know when they come to us, you can have a look at what these reference implementations of the national curriculum do. That can give you some idea of what they might have done. Now, I'm trying to phrase this super carefully because I've seen so huge differences in how much the kids really took from this. It's hard to say. Yeah, the others, if you want a quick look, the backside revision questions give you a very, very short summary of what the topics are that they probably have covered. That's for GCSEs, I think. And these are some, that's a different thing. I can comment on that offline. It's probably not so relevant for us now. So yes, the national curriculum is quite short. Several people have jumped in to fill that with more detail and life. So you just have to dig these things up. All right. A little focus on Key Stage 3 because we try to target them. Why? Well, it's very interesting things start to happen to some degree, and primarily when they choose GCSE. So this is the point where we can now impact. If we can convince a few more students that computer science is interesting and is approachable to them, they have the choice at this time to choose it. And that probably sets them up for a different trajectory. This is, again, the topics from the national curriculum for Key Stage 3 pulled out. If you're looking for some lesson topic, try to find one of those bullets that it connects to. Now, it shouldn't replicate really what they do in school. Otherwise, right, they come to your lesson and say, oh, yeah, we've done this just last week. I'll go and snore. But it's helpful if you can tie what you do a little bit to something that they already know. So that's just for your convenience, the list again. This is same curriculum as before, just the Key Stage 3 link. There's a specific subpage on this forum, Computing at School for secondary school, but this, again, I find it time-consuming to navigate. Any questions so far on this? So what we covered is what the students are supposed to have seen.
Start my computer science GCSE in year 9 because I was in Europe last year.
So that's the question about when the national curriculum came into force. So this says published 2013, but it definitely takes the schools a few years to implement it. There was some transition period. Yeah, I mean the
Computing drivers, so the ECBL is done mostly for schools rather than for students, because the way schools are measured on their attainment progress is on a measure called progress attainment rates. And they have their science bucket and the other things bucket. And because each whatever school is a science subject, if you pass that, it's equivalent to getting an A star in a science subject as far as the school's reporting measure. If students go through and spend 2 days doing Word, they can get equivalent to an A star in their metrics. So it's a complete scam. I think we had to do it over like 2 days. And it was yeah, but for them it's really good.
yeah, I think this is a point to pick up on. Apart from the curriculum and apart from teachers maybe needing to skill up, etc., and learn new things, there's other pressures on schools which are not very healthy sometimes. They compete in these leagues. No, you know, competition can be fruitful, but as soon as you start to measure something, that measure is no longer a good indicator of the actual thing you're trying to measure, because people start playing games. Yeah, that's quite pronounced in England, I would say, or England, Wales. Yeah, it's a bit unfortunate.
Another reason I should being so short and abstract is I think when it first came into force, before then, books were the curriculum and schools would buy books, their curriculum. So I assume there was some lobbying from the people who wrote the books to keep it shorter. But also,
I see.
In Key Stage 4, the national curriculum sort of forms the exam specs, which are much more fleshed out in detail than was actually taught. So I guess depending on what level of schooling you're in, there is that second level that's needed at Key Stage 4 as to what you actually have to teach. And there's also
that's interesting.
I imagine that's sort of the thing. If you have a really shallow curriculum and a bunch of teachers who aren't actually computer scientists, but are IT teachers or PE teachers who just took a 3-week course, which is what my teacher did, and aren't understanding the topic properly, then they can't go much beyond the spec because they weren't taught the spec in their 3-week course. Beyond the spec in their 3-week course.
Okay, this is 2 points I want to put on the recording as well. So one is for specifically the GCSE part, there is a spec for the exam, and that might be fleshed out in much more detail than the national curriculum. Right? Keep the national curriculum short so that book publishers have a better chance to flesh it out. It didn't seem to work out for computing, not that I know of. I also know there's no standard books for computer science. They're just popping up now, written by academics at universities. So it's weird why the publishers didn't pick up on this more.
I guess it was
yeah, if computing is perceived as a niche, yeah. Right. The other thing you pointed out is that the teachers might just have had some crash course and not really studied computer science. That might still be true, but it's getting a little better over time. So more and more schools have a proper teaching a proper computing lead who learned the subject like you did, right? This is one of the outcomes of this module might be that you go into teaching. At least that's the goal is to give you a taster of what that might be like.
The other side of where the teaching came from was the culling of IT. Because my teacher was an IT teacher, he realized that they were going to kill IT soon, and so he
I see.
into computer science. And I imagine a lot more people did that as well. So a lot of people working now. If you have a computer science degree, probably don't want to be working in high school with terrible pay and terrible benefits and all the rest. When you could go to A-level, significantly better, and actually have an interest in curriculum, because the A-level curriculum is the same as the GCSE, but more depth. At least it was when I was in it.
Well, one thing, okay, I don't know about the pay at sixth form versus secondary, but I know that the teachers that left us go into high schools, they often start right at the level of a computing lead, and that's paid substantially better than the other standard entry-level teachers. So because there is a short supply, they can actually get better salaries. If that stacks up against an industry salary is a tough call, but industry starting salaries are also not brilliant for everyone. No, you can't, yeah, don't compare with Silicon Valley salaries. That's because the living costs are so absurd. I think a standard starting cost for an IT professional here, if you leave after bachelor's, say, maybe 30 grand is a good starting salary, and that's probably what a teacher can make in a few years as well. So the gap is not as huge, but
because there's no computer science teachers, like they'll pay for all your teacher training and they'll give you a massive bursary. And then if my computer science teacher, who did a degree in computer science, she got all of her student loan written off after 5 years teaching. So
yeah, so there's some perks. The schools are trying hard. Yeah, it's good to hear. I hope this incentivizes the right people, right, to go into teaching. Let me touch on this last bit. I'll keep it short, but I think you need to know about the terms at least. So widening participation, maybe the term is self-explanatory, but I don't think it actually is, in the narrow sense that the university sometimes understands it. The core idea is to bring pupils from all sorts of backgrounds to university that otherwise would be underrepresented for whatever reason. It's been a big goal, especially in the Russell group. They put this on their agenda, etc. Our taster days are officially also part of this. I usually try to invite schools from less affluent areas to come, but I also try to mix it a bit because I don't think we should overdo it. But it's an attempt to bring schools that haven't been here before. So try to reach many different schools and show them at least, you know, there's a campus. There are people doing computer science. They're not running around in weird clothing all the time. It's simple things sometimes. There's a central team, so the university makes the statement that they take this serious, and they have a central team that has funding and has capacity to run programs. It's still more than they have a scholars program where they have kids over several years come for different events. So I think they're doing quite a few good things there. Now my understanding is that widening participation is often focused on something relatively narrow, which is a bit unfortunate. And it comes from the fact that this is easy to measure. So what people often look at is the polar data set. I think this is still the most recent comprehensive one, even though it's quite a few years ago. I didn't put the number down. I think it's more than 10 years old, if I remember correctly. So what this data set has is for each postcode, you know, small area, how many of the 18-year-olds, 18 to 20-year-olds? Should have written down the precise definition. It's a little age bracket that would be the traditional age to go to start a university course. What percentage of the population in that age group is pursuing some higher education? And then you divide these percentages into quintiles. So the quintile 5 means that's the 20% of postcodes with the highest percentage of students in higher education. Okay, so that is clear how the data is to be read. And I mean, you see Liverpool is basically all quintile 1 with a few exceptions in the center. Same for Birkenhead and large areas around Liverpool as well. So again, I think the data is a bit dated. I don't know how much this has shifted. It's probably still true that the Liverpool city area is relatively underrepresented in higher education. So if you want to flip it to something positive, it's relatively easy to make some impact with relatively simple terms. So if you just show that university is an achievable goal for a few more students, specifically in computer science, that can have quite some impact. We had some lovely, just from the kids that we had here last year. We talked to them informally a bit and then asked them in some surveys and so, and there were a few commenting, "Oh, this was so cool. I never thought I would like it," and blah blah blah. And now I'm definitely doing computer science for GCSEs, and it's just a handful that are so enthusiastic, but it's a handful that you really could potentially set on a trajectory for their life, right? So that's what you should aim for. I think that's a good justification for spending some extra time with them. Okay, I tried to put that into actionable advice for your lessons from all of today. So I mentioned this already. Maybe this is less important now because there's more material available, but teachers are often quite keen on picking up new ideas. Maybe not exactly your lesson, but some new cool thing that they can apply. They're usually very open. I think the most important bits for me are these three that I mentioned before. Try to make your lessons relatable. So picking up things that the kids would already know, whether or not they're into tech, whatever that is, right? And try to make it relevant to them and make it achievable on different levels. If you build activities where there's some competition or some competitive element in it, try to build it so that there's a little level of success that everyone can have, and then leave some space for those who are more advanced and more demanding to have some more sparring partners there, right? I think as a last comment, I just want to rephrase widening participation. I think the idea is brilliant and great and broader. It often is reduced to this postcode game, just because that's easy to measure. But of course, there's many other disadvantaged groups. If you, I don't have the numbers for, well, for women, you can probably look at the numbers easily. Yeah, some things are harder to measure. But at least you can aim to be inclusive beyond just the narrow definition of widening participation. That's my goal for the taster days.